A pleasant day, everyone. I am Abegail Guzman from BSE 3B Mathematics. In this video, we are going to discuss a topic about Wilson's theorem. So, Wilson's theorem states that if p minus 1 factorial divided by p or mod p, where p is a positive prime numbers, the remainder is congruent to negative 1 modulo of p, or simply remainder p minus 1. So, the quantity of 7 minus 1 factorial mod 7 is congruent to negative 1 mod 7. So, 7 minus 1 is equal to 6 factorial. So, it will be 6 factorial mod 7 is congruent to negative 1 mod 7. So, 6 factorial is equal to 6 times 5 times 4 times 3 times 2 and times 1 is equal to 720. Then the answer will be 720. Then we divide it to 7 and the answer will be 102. Then we will have a remainder of 6 because as we look at the formula, it says that the remainder is congruent to negative 1 modulo of p, or simply remainder p minus 1. So our remainder will be 7 minus 1 is equal to 6. That's why our answer is 102 remainder 6. And to check if we have right answer, 102 times 7 is 714. Then we add the remainder 6. Then we will have the answer of the 6 factorial. For the second example, we have the quantity of 11 minus 1 factorial mod 11 is congruent to negative 1 mod 11. So 11 minus 1 is 10 factorial mod 11 is congruent to negative 1 mod 11. So 10 factorial is equal to 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is equal to 3,628,800. So 3,628,800 mod 11 or divided by 11 is equal to 329,890 remainder 10 again because 11 minus 1 is equal to 10. So our remainder will be 10, and to check if we have the right answer, 329,890 times 11 is equal to 3,628,790. Then we add the remainder 10. Then we will have the answer of the 10 factorial. For the last example, we have find the remainder of 67 factorial when divided by 71. Using Wilson's theorem, we have that 70 factorial is congruent to negative 1 mod 71. Decomposing the factorial, we get that 70 times 69 times 68 times 67 factorial is congruent to negative 1 mod 71 times negative 1 times negative 2 times negative 3 times 67 factorial is congruent to negative 1 mod 71 times negative 6 times 67 factorial is congruent to negative 1 mod 71 times 6 times 67 factorial is congruent to 1 mod 71. Now, let's find a modular inverse of 6 mod 71 by the division algorithm. 71 is equal to 6 times 11 plus 56 equals 5 times 1 plus 11 is equal to 6 plus 5 times negative 1 times 1 is equal to 6 plus the quantity of 71 plus 6 times negative 11 times negative 1 times 1 is equal to 71 times negative 1 plus 6 times 12. Hence, 12 can be used as an inverse. Thus, 12 times 6 times 67 factorial is congruent to 12 times 1 mod 71 times 67 factorial is congruent to 12 times mod 71. Hence, when 67 factorial is divided by 71, the remainder left over is 12. So that's the end of our video. I hope you learned something from this lesson, and thank you for listening. Keep safe and God bless everyone.